Oh, just started the stream just in time for it to tell me there is an available update. Yay. I do have, I did turn on some auto update stuff from my computer, and since this is Linux, I install Visual Code through apt. So I'll be updating it through there as well instead of through their own system. But I couldn't figure out an easy way to turn off that message, like to fully delay it, which is a little bit annoying. But before we get started, let's go ahead and share out our channel to the world. Out to Twitter. Out to for devs. Perfect. Okay, so we'll be continuing on today with, where are we? Computing the size of a non-recursive type. All right, so recall the message enum we defined in listing 6.2 when we discussed enum definitions in chapter 6. So we have an enum message here. It has just quit, move, which is a struct type, anonymous structure. So it takes an X and a Y. Write, which is a string. Change color, which is a triple I32s. And message could be any one of these. To determine how much space to allocate for a message value, Rust goes through each of the variants to see which variant needs the most space. Rust sees that message quit doesn't need any space. Message move needs enough space to store 2 I32 values, and so forth. Because only one variant will be used, the most space a message value will need is the space it would take to store the largest of its variants. Contrast this with what happens when Rust tries to determine how much space a recursive type, like the list enum listing 15.2 needs. That would be this one. Therefore, cons needs an amount of space equal to the size of an I32 plus the size of a list. To figure how much memory the list type needs, the compiler looks at the variants, starting with the cons variant. The cons variant holds a value of type I32 and value of type list, and this process continues infinitely as shown in figure 15.1. Using box type to get a recursive type with a known size. Rust can't figure out how much space to allocate for recursively defined types, so the compiler gives the error in listing 15.4, but the error does include this helpful suggestion. Okay, so help, insert indirection. So yeah, they gave us that when we ran into that problem. In this suggestion, indirection means that instead of storing a value directly, we'll change the data structure to store the value indirectly by storing a pointer to the value instead. Because a box T is a pointer, Rust always knows how much space a box T needs. A pointer size doesn't change based upon the amount of data it's pointing to. This means we can put a box T inside the cons variant instead of another list value directly. The box T will point to the next list value that will be on the heap rather than inside the cons variant. Conceptually, we still have a list created with lists holding other lists, but this implementation is now more like placing the items next to one another rather than inside one another. Good morning and stacking. We can change the definition of the list enum in 15.2 and the usage of the list in listing 15.3 to the code in listing 15.5, which will compile. So we ran into trouble when we tried to implement it, and it said like, hey, you can't do that exactly the way we tried to. So let's see. Okay, so enum list, cons I32 box list nil. So we got that far. And then it's, okay, use list cons and nil. So we have that. And then function main, let list equals cons1 box new cons. Okay, so we didn't get the box new. We were sort of playing around with this. I'm excited. I took off the next 2 days, so after the stream, I'll take my first stab at Rust. Awesome! I can't wait to see or to hear what you build. Good morning, Miguel. Stacking, are you going to go through the book here, or are you just going to you're gonna build something? All right, so let list equals Wonderful. Thank you for the host. I think that's the first host that I've gotten for this early morning stream. You have to look at the book since you only picked the stream up halfway through. Yeah, and then the book is also available for purchase now since I have started. So obviously you can go look at the streams that I've done, but also you can purchase the book at any bookstore, or you can also go and just look it up online. There's lots of ways to find the book. Okay, so let list equals, and what do we want? It's going to be a new list. And if we do this in multiple things here, it's going to be this cons. So I need to go back and see if I missed anything fundamental. The first 6 or so chapters were like the super fundamentals of Rust. Okay, so cons, and this is going to be an I32, so if we say something like 1, and then it's going to be box new, and then a new list. So how do I want to do that? Cons. Is it just, yeah, it's cons. That. I don't think I need list. Do I need list? Oh no, I have cons already like this. So it's just cons. So cons1 box new cons, and this will then be like 2 box new cons 3, and then we'll just say nil. So we'll just go 3. And definitely need to practice the lifetimes and maybe play a little bit more with closures. We have those articles that that we've had printed out on the Learning Rust wiki, so those might be really good to look through as well. Okay, so mismatch types. Oh, it's not here like this. It would be cons, no, like that. We just do 2. This function takes 2 parameters, but 1 parameter was supplied. Am I creating the enum wrong? Cons 1. Oh, it's a box. Right, okay, so instead of box now like this, box new, it could be cons 3 box new nil, like that. This function takes 1 parameter, but 2 parameters were supplied. Cannot find value cons 3. Oh, cons. So box new cons 2, box new cons 3. Expected 1 of, and so, oh, look at that. Expected 1 of question mark or an operator found semicolon. Interesting. Am I missing? Not missing a parentheses. So this is the same problem we ran into last time, which is, okay, expected one of these things, and it's not working out the way I wanted it to. It feels like, okay, so let list equals cons1, comma, box new. So the other way to do this would be, okay, let, I comment you out, let list equals cons1, comma, box new, and this is going to be cons, right? Yeah, cons 2, box new, cons 3, box new, nil, and at the end of it, semicolon. Yeah, so I just screwed up somewhere in here. Writing it all in one line is really tough. So that's the reason why that didn't work for me. But this one does, and so if I attempt to print it out, so print line, the list is, let's see what happens. List. We'll save it, and list doesn't implement standard format display. So we can give the debug, but it's probably gonna yell at us for that too. We need the standard format debug. What is that? It's format debug. It usually tells you right here, which is add a hash derive debug. That's what it is. Hash derive debug. That. Oh, I think I didn't do it right. Is it lowercase d's? Cannot find debug. Help try debug with a capital D. All right, let's see if this can print out. Cargo run. All right, so we got the list. Okay, so we just finished this part. The cons variant will need the size of an I32 plus the space to store the box's pointer data. The nil variant stores no values, so it needs less space than the cons variant. We now know that any list value will take up the size of an I32 plus the list of a box's pointer data. By using a box, we've broken the infinite recursive chain, so the compiler can figure out the size it needs to store a list value. Figure 15.2 shows what the cons variant looks like now. And I think even though we know that it's recursive, it is actually breaking the recursion here because the contents of box is stored on the heap. And so it's not, the list doesn't have to actually store this box at all. Like it doesn't have to carry it all because this is inside of this box, and this box is the only one that needs to be stored by the list in the stack. Basically, it just says, hey, you know what? This points to an area in memory, which itself points to an area in memory, but the heap can infinitely grow and shrink as long as you have that available memory. It just won't matter. Okay, so here's what it sort of looks like now. Boxes provide only the indirection and heap allocation. They don't have any other special capabilities like those we'll see with the other smart pointer types. They also don't have any performance overhead, and these special capabilities incur. So they can be useful in cases like the cons list, where the indirection is the only feature we need. We'll look at more use cases for boxes in chapter 17 too. The box T type is a smart pointer because it implements the Deref trait, which allows box T values to be treated like references. When a box T value goes out of scope, the heap data that the box is pointing to is cleaned up as well because of the drop trait implementation. Let's explore these two traits in more detail. These two traits will be even more important to the functionality provided by the other smart pointer types we'll discuss in the rest of the chapter. So what I believe happens is, as soon as main ends, or whatever function that we've given ownership of this list to, it goes down and says, okay, hey, you box new, you're like the lowest and the furthest deep into this this pile of boxes. You need to be unloaded from heap. And then it just reverses back and says, okay, now you get unloaded, now you get unloaded, then finally you get unloaded. And that's how ownership can be maintained through to the very end. Miguel, awesome. You're gonna help out stacking potentially. Stacking also, don't forget that on the Learning Rust, we have this wiki here. I don't know how super helpful it's going to be for you, but I have put in some things that have been helping me, like methods that I found on stirs that really, like, sort of just for the projects that I've been working on. I haven't been adding them from the book as I'm reading them. But if you find anything, feel free to add to that learning wiki, because I have made it usable as a wiki from anybody who has a GitHub account. All right, treating smart pointers like regular references with the Deref trait. Implementing the Deref trait allows you to customize the behavior of the dereference operator, star, as opposed to the multiplication or glob operator. By implementing deref in such a way that a smart pointer can be treated like a regular reference, you can write code that operates on references that use that code with smart pointers too. Let's first look at how the dereference operator works with regular references. Then we'll try to define a custom type that behaves like box T, and we'll see why the dereference operator doesn't work like a reference on our newly defined type. We'll explore how implementing the deref trait makes it possible for smart pointers to work in a similar way as references. Then we'll look at Rust's deref coercion feature and how it lets us work with either references or smart pointers. Following the pointer to the value with a dereference operator. A regular reference is a type of pointer, and one way to think of a pointer is as an arrow to a value stored somewhere else. In listing 15.6, we create a reference to an I32 value and then use the dereference operator to follow the reference to the data. Right, so we have, okay, let x equals 5, and then y equals a reference to x. So of course, a reference in this case in the stack doesn't just point to the area. It is actually an area in memory that says, okay, here's the location of where the memory is, here's how long it is, and here's any other metadata that the compiler needs to know. So it's not just purely a reference to x. It's this is an actual area in the stack that includes a pointer to x. So assert equal 5 and x, that's correct, and assert equal 5. And then the star dereferences and pulls the value out right at this moment. The variable x holds an I32 value, 5. We set y equal to a reference to x. We can assert that x is equal to 5. However, if we want to make an assertion about the value in y, we have to use star asterisk or dereference y to follow the reference to the value it's pointing to, hence dereference. Once we dereference y, we have access to the integer value y is pointing to that we can compare with 5. If we try to write assert equal 5y instead, we would get a compilation error. Can't compare integer with reference to integer. It's common to call it star y. I'll try to remember that. I often have used asterisk to in the past, so if I slip up, that's forgive me. Otherwise, I'll try to remember it star. Comparing a number and a reference to a number isn't allowed because they're different types. We must use the dereference operator to follow the reference to the value it's pointing to. Using box T like a reference, we can rewrite the code in listing 15.6 to use a box T instead of a reference. The dereference operator will work as shown in listing 15.7. So we have let x equals 5, let y equals box new of x, assert equal 5 is same as x, and assert equal 5 is same as star y. So we haven't changed anything yet. The only difference between listing 15.17 and listing 15.6 is that here we set y to be an instance of a box pointing to the value in x, rather than a reference pointing to the value of x. In the last assertion, we can use the dereference operator to follow the box's pointer in the same way that we did when y was a reference. Next, we'll explore what is special about box T that enables us to use the dereference operator by defining our own box type. Just to be clear, do we need both the construct and box for this recurrent list? It feels like we use any struct that has a field which points to heap allocated data. Or do I need to rewatch yesterday's stream? I believe that you're right, because it actually said that box, it is similarly implemented to string, like the capital string S, capital S string. So let's try this. If we have cons list i32 box, let's create another list here. So enum string list, and this will also be a cons, which sort of, I guess we can't call it cons. We'll call it just like essentially a linked list here. Maybe I'll just call it capital C to differentiate it. And this will take an i32 and a string. What do we put in a string of list? It's just that. Or I can't really do types of strings. I guess I could just do string, but I would really want to be able to put in okay, how do I say it's a string of list? Or maybe, because I can't necessarily say, yeah, I'm not exactly sure how to do it, actually put it in here to tell it that it's going to be a recursive. Because okay, so if C is essentially a tuple here that takes an i32 and a string, I guess that's all that would be. Can I then say the third thing here would be a string list? So it's a 3-level tuple. Recursive type string list has infinite size. Recursive type is infinite size. Insert indirection, e.g. Oh, so you know what the problem? The problem is not the string. This is fine. The string list, I can't store this data in a string. It has to be stored in some kind of container box that would live on the heap. So I think the idea is that if there are other ways to do that, and it does give us some suggestions, box, RC, or reference at some point. So maybe I could just do a reference to a string list. Missing lifetime specifier, but then we have to lifetime specify it, which we don't have to do up here. Use of undeclared lifetime name A. So I think what that's enum that. Oh no, it's enum like that, isn't it? Expected identifier. What do I set lifetimes on enums? I've already. Is it on this side or is it on this side? Missing lifetime specifier. Oh, interesting. Gave it a lifetime specifier. Enum lifetime should be correct, but it was yelling at me. Okay, so if I go back to this where it's yelling at me about that, and I come back here, and I say you are enum A, like that. Expected identifier found that. Okay, let's go take a look at the Rust lifetime enum. Stack Overflow. Looking to see if I could find the okay, so I'm not necessarily seeing anything that's like for the Rust by example book, which would be really nice, but let's just go to enum temporary valuable. Let's do this. Oh man, this is taking forever to load. Well, I've only dropped 16 frames in the entire stream, so okay, so enum security. What you're trying to achieve is impossible. Wait, what? Wait, this isn't. I want a lifetime with enums. This is the 1.0 book. Okay, let's check Stack Overflow. Try them. Okay. What was his question? I don't understand why I get an error with this type of structure. Enum cell, he's putting a lifetime here on this side. And he's doing the references in the same way that I am over here. Yeah, sorry, maybe it wasn't clear. It meant that you don't need cons. So just like an enum like this, enum, some enum. Okay, let's go try this. So enum, some enum. So we'll just do some enum. Some field I32. So okay, so it's gonna be a tuple box sum enum nil, or in this case enum string list. You don't need cons. Yeah, you don't need I mean, cons is the list, so it's just the word that we're using that names the title so that we know what we're putting in here. But I don't think it matters that much. We just need something in here. It could be C like this. And then we'd use it by going some enum : C, parentheses, an I32, and then something else. So yeah, that's all we need. I'm gonna erase this because it's not really part of our what we want to commit up. Let's get back to the book. All right, defining our own smart pointer. Let's build a smart pointer similar to the box T type provided by the standard library to experience how smart pointers behave differently than references by default. Then we'll look at how to add the ability to use the dereference operator. The box T type is ultimately defined as a tuple struct with one element. So listing 15.8 defines a myBoxT type in the same way. We'll also define a new function to match the new function defined on box T. So it's just struct myBoxT. So we're using generics here, and then a tuple of unknown type. So let's implement that. So struct myBox generic T and implements type here. So it's a tuple struct. Then we're going, actually I don't need that. We're going to implement myBox, and we're going to have implement, oh right, we have to have the generics here too. T myBox T. I was a bit confused because cons was imported specifically from list. Right, yeah, I think they're just trying to save a little bit of space in typing. They're just using this list to get cons and nil out of it. They're being tricky here, but yeah, it sort of does, like if you only see this part, it'd be really confusing. You think, well, cons is now a default type provided by the language, right? Implement with a generic type, myBox generic type, and then we have function new. So what are you on about? Expected one of or where found implement. Wait, do I need a semicolon here? Do. Now you're just saying you're never using it. Okay, so function new. Now we're going to take an X, which is type of this generic T, and we're going to return to myBox. So we're going to take an X, which is type T, and we're going to return a myBox with like that. Yeah. The way VS Code highlights cons and yellow it does make it seem like Rust reserved type world. I know it kind of does. I wonder why it's making it. I wonder if there is a cons that is reserved from some other language maybe that Rust is aware of. Or is it because it's part of an enum or a tuple? I don't know. Oh, you know what? I do hello. That's what it is. It's the parentheses. The parentheses are making it yellow. That's why. Okay, so in here we just want to now return myBox and pass it in X here. So myBox, pass it in X, and we're going to return that. So of course it's saying this method is never used. So if we wanted to use this down here, we can say also oh, weird, what happened here? Print line. Okay. Add that in. tab u in. Okay, so we want to say let my box equals my box new, and then I want to pass it in something like 55. So that uses that. Of course, my box is empty now. If I want to do the exact same thing that we have here, I can now maybe print line my box is, and my box, and I would want to dereference this with a star. Which of course, it won't let me do that because the type my box integer cannot be dereferenced. And if I do this, it doesn't implement standard format display or any of the other stuff. So let's go back and see what they're going to have us do. We've defined a struct named mybox and declare a generic parameter t because we want our type to hold values of any type. The mybox type is a tuple struct with one element of type t. The mybox new function takes one parameter of type t and returns a mybox instance that holds the value passed in. Let's try adding the main function in listing 15.7 to listing 15.8 and changing it to use the mybox t type we've defined instead of box t. The code in listing 15.9 won't compile because Rust doesn't know how to dereference mybox, which is that's like literally exactly the same thing. So that we had here, which is it won't let us do this because it doesn't know how to do that yet. Here's the resulting compilation error, just cannot be imp dereferenced. Our mybox t type can't be dereferenced because we haven't implemented that ability on our type. To enable dereferencing with the star operator, we implement the deref trait. As or treating a type like a reference by implementing the deref trait. As discussed in chapter 10, to implement a trait, we need to provide implementations for the trait's required methods. The deref trait provided by the standard library requires us to implement one method named deref that borrows self and returns a reference to the inner data. Listing 15.10 contains an implementation of deref to add to the definition of mybox. So we're going to implement deref for mybox. That's adding this trait in. Type target equals this generic type, and then function deref. Okay, takes a reference to self. It returns a reference to the type, and then self.0. Because it's a tuple, we want the first one. So let's go ahead and implement this. So up here we have implement type mybox. This is going to be implement type, is it deref with a capital D? It is. Deref for mybox. For mybox with T as a reference there. And cannot find trait deref in this scope. I'm going to need to, use standard ops deref is what it's telling me. Use standard ops deref down here. So that will take away this error. Now I have not all traits implemented, missing target. So now I need to say, is it target with a capital T? Oh, nice. It gives me the full documentation for it. So basically I need to say type, so type target equals. So type target equals, it's just going to be this generic type here. And then we're going to just want to return, then we want to have this function deref here. Okay. Which takes in a reference to self it's going to return a dereference. Is it a reference or a dereference? A reference, the type T, because we're dereferencing it out here, okay? And then we're going to want return self.0, but null trait items implemented, missing target. Can you take 2 seconds to explain the type target equals T? Well, I think I've got it wrong, so let's make sure. First of all, type with a lowercase t. All right, so type target equals T. So what we're doing is this is different than like the other implementation stuff that we've had before, because we're not just saying, hey, add in a function to it. It's more of we're saying like, hey, let's add in this trait, and this trait happens to be called deref, and there are derefs already. So we're just saying, hey, the type that we're targeting for this generic, the type that we're targeting for this trait is this generic T. So it's going to create this implementation for every single type that in Rust standard library. I guess target is a trait of deref. So we're just setting that to 0. Okay, and that's something interesting too. I'll get to this in a second. So we're going to set like the type to this target. Now the reason for that is because we can now implement this specific trait that we're creating on any type that that implements this type right here. So that's sort of like allowing us to filter and say like, okay, what type is this going to be for? That this trait is going to be available for. Okay, then we have our function deref, which is our special function that we're overriding here, because you notice we don't call deref by name. We only have the star next to the variable name, and that's calling the deref function for us. It takes in a reference to self, which is, so this is part of just implementation, implementing functions, and it's going to return a reference to the generic type. And inside of here, what we're returning is the self.0. And so this is odd to me because I don't really see the numbers after the dot in like diving into data structures, but we have the data structure of a tuple for this type, and we want the first item in that tuple, so it's .0 for tuples, and that's it. That's the only way to get into them, and that's the only type that we get into through just a number after a dot. I guess target is a trait of deref. Oh yeah, so, and then of course we want a reference to it so we can dereference it properly with the star. So that is my quick, slightly longer than 2 second explanation about what's going on with this code. It's a little bit crazy, and it requires you to know tuples, so you know how to do this. General references, so you know, do the reference here. Generics for the types, and just general. We already went through. They already went through in a previous chapter the type target too. All right, so in the next paragraph, they shortly explain the type part. If it's still unclear, you might want to read up on how iterator trait works. In my opinion, the associated type makes more sense in that case. All right, then let's read those paragraphs. The type target equals T syntax defines an associated type for the deref trait to use. Associated types are a slightly different way of declaring a generic parameter, but you don't need to worry about them for now. We'll cover them in more detail in chapter 19, so we just have to wait for 4 more chapters. We fill in the body of the deref method with self.0. So deref returns a reference to the value we want to access with the star operator. The main function in listing 15.9 that calls star on the myBoxT value now compiles, and the assertions pass. Let's make sure that's true. Did I lose? Oh, reference. I'll have to spend some extra time with generics. Yeah, I'm a bit weak on generics too, but I think that's mainly because I haven't seen reasons in my own code or like a real life project where I'm gonna need them. It sort of feels to me that generics are really good for libraries, where like I want to reuse the code a lot, but I haven't seen that too much yet. At least reuse the code with different types. Usually I reuse the code with the same type. Okay, let's run this and see. Let's see it in action. Cargo run. My box is 55. And so that's working with right here, box. Which means I can put 55 in here, but I can also put that my string box equals my box new, and we can hand it something like hello world. Print line, my string box is, and dereference my string box. All right, this should also work. And so that's the power of the generics for us, is that we don't have to worry about like doing anything with my box here. It can handle whatever type we want to hand it. Without the deref trait, the compiler can only dereference ampersand references. The deref method gives the compiler the ability to take a value of any type that implements deref and call the deref method to get an ampersand reference that it knows how to dereference. When we entered *y in listing 15.9, behind the scenes, Rust actually ran this code, *y.deref. Rust substitutes the star operator with a call to the deref method and then a plain dereference, so we don't have to think about whether or not we need to call the deref method. This Rust feature lets us write code that functions identically whether we have a regular reference or a type that implements deref. The reason the deref method returns a reference to a value that the plain dereference outside the parentheses in *y.deref is still necessary. I think this is still necessary in the ownership system. This sentence is really weird. Still necessary is the ownership system. Oh wait, no, okay. The reason deref method returns a reference to a value and that the plain dereference outside the parentheses in this is still necessary is the ownership system. So the ownership system is the reason why we have to do that. If the deref method returned the value directly instead of a reference to the value would be moved out of self. We don't want to take ownership of the inner value inside of myBoxT, in this case, or in most cases where we use the dereference operator. You notice a few times the book tries to get a little bit too wordy. Yeah, it does that sometimes. Note that the star operator is replaced with a call to the deref method and then a call to the star operator just once, each time we use a star in our code. Because the substitution of the star operator does not recurse infinitely, we end up with data of type I32, which matches the 5 in the assert equal in listing 59. And this looks like it might take us a little bit longer than 5 or so minutes to get through. So I'm just going to go ahead and not add any new content and sort of begin to wind the stream down. But let's go ahead and update where we're at. So I'm at here. Let's open up code here also. Okay, so in the README, where are we at? Currently at. So we're now going to be at implicit deref coercions with functions and methods. Click on that, and it'll take us to the appropriate link. All right, so this is our current location. I do not need. There is no "Don't remind me at all" anymore button, which is really sad. Okay, so we have this. Let's go ahead and update where we're at. So right here we have main RS. We can put this in is implemented our own box type and updated where you're at. Go ahead and push those on up to GitHub. The good news, we got through 745 without any drop frames. So looking at the log, we got 16 drop frames sometime in the last 40 minutes or so. The World Cup is over? I don't think so. The World Cup, I think, is like the last few games are being played. And then it'll be over. But Wimbledon is on too. Before the stream ends, you might want to do a Rust up update. The docs have a serious code exploit that the team had. Ooh, okay. That is actually a really good idea. So we just sent that code up. Let's just do that for right now. It's over for England. Oh, England lost? They played against Spain, right? Or did they play against France? I can't remember anymore. I know that like France has been just rolling over everybody. That's all anybody at work is talking about right now. Okay, so we want to do a Rust up. It is just a plain update. So let's go ahead and get that updated. Croatia, 2-1 win for Croatia. Okay. I wonder who Croatia is gonna then play. Okay, so this will just go through and interesting. So it's removing a bunch of stuff and it's gonna reinstall. Trouble with the England team is that they score 1 goal, then just try to stall. Oh, so they were, rather than try to score more goals, they try to play it like they try to do the safe way, which is score a goal and then just play defense. Or I guess like it's a weird hybrid between like a really good defense and a stalling offense to just run the clock out of time, which works in low-scoring games. And like I know that that soccer or football, or I think, what is it? Cool 18 Online called it something like hand soccer football, something like that. Hand foot kickball. I don't know. So, oh man, this is removing a component Rust C. Oh, right, because we installed the nightly version at one point in time, so it's updating that too. So now we're gonna have the latest version of 1.27, and we're also gonna have the latest nightly, which is 1.29. The patch update has a cool little blip from the Rust team that stated they're really hitting problems with Rust compiler and they need LLL to get done before they can really move forward. Ooh, that'll be nice. That sort of like force them to work on that. I know that's a huge update though, and I just hope they don't rush themselves to get it done. I hope that they can do it incrementally too, and not just like, wait, gigantic update that changes everything. All right, so we have this updated. We have a brand new version of Rust installed. We have Rust.1.27.1. Is it on a Rustling website? Let's go take a look. Is it Rustling? I can never remember if it's .com or .org. It's rust-lang.com. Where do they have? Is it? The patch notes. Where Rust.27? Here's the patch notes. The Rust team is happy to announce a new version of Rust. This patch release fixes a bug in a borrow checker verification of match expressions. This bug was introduced in 1.26 with the stabilization of match ergonomics. We are uncertain that this specific problem actually indicated unsoundness in the borrow checker, but suspected that it might be a possibility, so decided to issue a point release. The code sample below caused a panic inside the compiler prior to this patch. So if we have function main, let a equals a new vector, empty string, toString, a.iter.enumerate, take while, then we have a closure which takes anything and then a reference t, and then just returns false, collect into a vector. It will reject the above code with this error message. With this reference t, cannot move out of borrowed content. To prevent move, use ref t or ref mute t, cannot move out of borrowed content. Alongside the match ergonomics fix, a security vulnerability was also found in Rust doc, the standard documentation generator for Rust projects. That vulnerability is addressed by the second patch contained in this release by removing the default search path for Rust doc plugins. This functionality will be entirely removed in Rust 1.28. This plugin infrastructure predates Rust 1.0 and has never been usable and stable and has been unusable and nightly for many months. Expect to hear more about the removal in the next release. The current patch removes the default search path. Instead, users must specify explicitly, while the next release, okay. So I'm guessing they had some kind of like, they just ran code arbitrarily that was in the search path for RustDoc plugins, and that code could be anything. Here's the Rust team talk about NLL. Okay, so NL cannot come soon enough. They have a mailing list for that. Where did they, I think, oh, this is gross. Like they're copy and pasted that. You just scroll past the Steve guy. Okay, Steve, here it is. We have a mailing list for you want to be, that's an interesting idea. Since people rely upon the borrow checker, any borrow checker failure that allows this should be considered a security vulnerability during Rust code review. Nobody's checking for UAF, unlike C++ code review. The likelihood that a borrow checker bug will lead to someone else. And then he says, I like this idea. The bugs happen because the current borrow checker is hard to work with. None of these bugs ever popped up with a new NLL borrow checker. This is part of why we've been working on LL so hard. It might suggest a few different things, possibly one of which is this feature should have blocked on LL. Hindsight is 2020. So yeah, I mean, like it sounds like they're looking forward to it as much as everybody else is in the community, which is pretty awesome. So can't wait till they get that out and we start taking a look at it. And we play around with it. It is probably just going to be one of those anticlimactic where it just, for us, it just is easier to write code, but for internally the Rust development team, it's just going to be amazing for them. All right, so with that, let's finish cleaning up this. Is there anything else we need here? No, so I can go on with you as well. And we don't need any of these open. All right, so I have all my code in this Learning Rust repo here. I have that linked in the stream description, and I'm also archiving these videos over to YouTube. And I have links to the this GitHub repo as well there. I'm doing these Learning Rust, going through the book streams every single weekday morning at 7 a.m. Mountain Time. And I have no plans not to do that again tomorrow morning. That was a terrible use of double negative. So I am planning on streaming again tomorrow morning and then again all of next week as well. We'll be continuing on right here, and then we eventually want to potentially go in and see if we can fix this problem. Like, it's not necessarily a full problem, but it might be good to sort of add this into the book as an issue. So with that, I am going to pause you. I guess that's been running in the background the entire time. I'm going to go on, get ready for the rest of my day, and I hope that you all have a great day as well. I'll see you all tomorrow morning.